Next, let's study about amplifiers. Amplifiers are the next big abstraction in electronic circuits. So we've looked at some other abstractions before, for example, the gate level abstraction. We also looked at various other forms, such as the Thevenin modeling of a much larger circuit. So one can view that as the Thevenin abstraction of a much more complicated circuit. Our next big abstraction is going to be that of amplifiers. So before we talk about amplification and amplifier devices, let's try to understand why do we care about amplification, okay? Signal amplification is key to both analog and digital signal processing. So what is amplification? Okay, let's take a look at why it is useful in the analog domain to begin, and then we'll look at why it is useful in the digital domain. So if you look at an abstract amplifier box, abstract amplifier device, I can draw a little box like this, and this is my amplifier. The amplifier has two ports, the input port and an output port. So this is my input port, and this is my output port. Now with the amplifier, the basic idea is this. If I have a signal that is pretty small, so let's say I have a sinusoid that looks like this, and this is my time axis, and I have a little sine wave, then what the amplifier might do is give me a much bigger sine wave. Okay, so it might amplify the signal by some factor, 5, 10, 100, whatever. Okay, so that's what a basic amplifier does. So why would an amplifier like this be useful? Why is it important to amplify signals? And so, I mean, of course, the obvious advantages are to be able to amplify sounds, music or other sounds, so that you can be heard further away. But what I want to show you is that amplification is much more fundamental in our field. It's very fundamental to communication in order to enable noise tolerance, okay, both in the analog domain and in the digital domain. So let's start with looking at the analog domain and why this might be key to noise tolerance in communication. So suppose I have some kind of a signal. Let's imagine I have no amplification. Okay, a basic system where I do not have any amplification. And let's say I have a useful signal that looks like this. Okay, so let's say I have a useful signal that looks like this. Okay, so let's say the peak to peak value of the signal is 1 millivolts. Okay, so it's a very small signal, about a millivolt. And let us say that I am looking to communicate this signal over some distance. Okay, so ideally, I would get a signal that looked like this. However, what if I injected noise into the communications channel? Okay, so if there was no noise, then everything would be fine and things would work perfectly okay. If I were to observe the signal at this point, the signal would look fine. But now let's suppose I inject noise into the system. Okay, so if I inject noise into the system, let's say I have some random noise in the system, and let's say peak to peak 10 millivolts. All right, so this is 10 millivolts noise, and let's say I inject it into the communications channel. And so what I get at the output, okay, much better. Okay, so I have a red noisy signal superimposed on my real signal. So what I end up at the end of it might be something that looks like this. Okay, so the noise has swamped my signal here, and so it is very hard to distinguish between the noise and the real signal. Okay, so the problem with that is if I'm a receiver, I don't quite understand what I have received. That is not nice at all. Okay, so let's try amplification. Okay, how might things look different if I were to amplify the signal? So as before, I have my noise. I'm still going to superimpose noise on my channel, and this is my channel. And let's say in this case, what I do is start with the same signal here. So the 1 millivolt peak to peak signal, it's a small signal. But this time around, what I'm going to do is I'm going to amplify the signal. Okay, so I'm going to take up my little amplifier, my AMP, and I'm going to amplify the signal so that what I get is a much larger value for my input. Okay, so then when I look at the output, supposing I had no noise, then clearly I would have a nice signal that looked like something like this. But now, supposing I've added noise, and this noise is going to be superimposed on my output signal. So in this case, I was going to be getting something that looked like this. Okay, so I should be a little careful here so I don't get non-causal values that tend to go backwards here. I progress forwards in time. So if you notice, this particular signal looks like I can still make out the input out here. So this is not bad at all. Okay, so by amplifying the signal, I was able to make out the signal even when there was noise superimposed on the signal. So this is not bad at all. Okay, this indicates that if I have amplification, then I